Hello friends, now we discuss what is the conjugate of a matrix. A matrix is obtained from the matrix A on replacing its elements by corresponding conjugate of complex number is called conjugate of matrix A and is denoted by A bar. Here, when we find out a matrix from a matrix A by replacing its element by corresponding conjugate complex number is called conjugate of that matrix A. Suppose that, for example, we can take a matrix A 1 plus I, minus I, 3 plus I and 3. Now we find the conjugate of the matrix A. This is conjugate of A. This is denoted by A bar. A bar can be found from the matrix A by replacing its elements by conjugate complex number. So the conjugate of 1 plus I is 1 minus I, conjugate of 3 plus I, this is 3 minus I, and conjugate of minus I, this is I, and conjugate of 3 is 3. So the conjugate of matrix A is obtained from matrix A by replacing its element by the corresponding conjugate complex number. You can see here the conjugate of matrix A, that is A bar, is obtained from A. Here when we replace 1 plus I by its conjugate complex number 1 minus I, 3 plus I replaced by its complex conjugate 3 minus I, and minus I replaced by conjugate complex number I, and replace complex conjugate of 3 is 3 here. So the conjugate of matrix A is A bar, which can be found from matrix A by replacing its element by the corresponding conjugate complex number. Now we discuss about some property of conjugate of a matrix. We know that if we find conjugate of a matrix, this is equal to A matrix. For example, if we take above, suppose that this is the B matrix, when we find conjugate of B matrix, so we replace this 1 minus I by conjugate complex number. So the conjugate complex number is 1 plus I. Conjugate of minus I is conjugate of I is minus I here, and conjugate of 3 minus I, this is 3 plus I, and conjugate of 3 is 3. So we can see here this is the matrix A here, and B is A bar. So conjugate of A bar is equal to A. You can see here. Now we learn about some other properties. Suppose second property is here. Conjugate of the A plus B is equal to sum of the conjugate of A and conjugate of B. This is the second property here. You can see here conjugate of A plus B, this is equal to conjugate of A plus conjugate of B. Let A is the given matrix 1 plus I, 3 plus I minus I and 3. Suppose that B is the matrix here. Suppose 2 minus 3I and 3 plus 7I and here 2I and this is 3 minus I. Now we find out conjugate of A matrix, that is A bar. We replace this 1 plus I by its conjugate complex number 1 minus I. Conjugate complex number of minus I, this is I. Conjugate of 3 plus I, this is 3 minus I, and conjugate of 3 is 3 here. Now we find complex conjugate of B matrix. So the conjugate of 2 minus 3I, this is 2 plus 3I. Conjugate of 2I, this is minus 2I. Conjugate of 3 plus 7I, this is 3 minus 7I. Conjugate of 3 minus I, this is 3 plus I. Now we find here A plus B. So when we find A plus B, we add the corresponding element of A and B. So we get here 1 plus 2, this is 3, and I minus 3I, this is minus 2I. 3 plus 3, this is 6 here. I plus 7I, this is 8I. Minus I plus 2I, this is I here. 3 plus 3, this is 6 minus I here. Now we find here conjugate of the matrix A plus B. So this is 3 plus 2I. Conjugate of I is minus I. Conjugate of 6 plus 8I, this is 6 minus 8I. And conjugate of 6 minus I, this is 6 plus I. Now we add conjugate of A plus conjugate of B. We can see here when we add 1 plus 2, we get 3 here. Minus I plus 3I, this is 2I. I and this is minus 2I, we get here minus I. 3 plus 3, this is 6 here. Minus I minus 7I, this is minus 8I. 3 plus 3, this is 6 and plus I. So we can see here conjugate of the matrix A plus B is equal to the sum of the conjugate of A and B. So this is the second property of conjugate of matrix A. Now we can see some other property, that is AB whole conjugate is equal to A conjugate into B conjugate. This is the third property. Now we find out a product of A and B. Here A is 1 plus I minus I, 3 plus I and 3 in the above example, and B is here 2 minus 3I, 2I, 3 plus 7I and 3 minus I. Now we multiply these two matrices, we get here, multiply first row by first column, we get here 1 multiplied by 2, this is 2, 1 multiplied by minus 3I, this is minus 3I, I multiplied by 2, this is 2I, I multiplied by minus 3, so this is minus 3I square is minus 1, so this is plus 3. And minus 3 multiplied by 3 minus I multiplied by 3, this is minus 3I, minus I multiplied by 7I, this is minus 7I square, or I square is minus 1, so this is plus 8. Now this first row multiplied by second column, 1 multiplied by 2I, I multiplied by 2I square, so this is minus 2. Minus I multiplied by 3, so this is minus 3I, minus I multiplied by minus I, so this is plus I square, but I square is minus 1, so this is minus 1 here. Second row multiplied by first column, we get 3 to the 6, 3 minus 3I, this is minus 9I, I multiplied by 2, this is 2I, I multiplied by minus 3I, so this is minus 3I square, so this is plus 3. And plus, so first row multiplied by first column, this is 3 to the 6, 3 minus 3I, this is minus 9I, I multiplied by 2, this is 2I, I multiplied by minus 3I, so this is minus 3I square, that is plus 3. 3 multiplied by 3, this is 9, 3 multiplied by 7I, this is 21I. I. Now we multiply second row by second column, we get 3 to the 6 I plus 2I square, this is minus 2, and 3 multiplied by 3, this is 9, 3 multiplied by minus I, so this is minus 3I. Here we can see this is 2 plus 3, 5 plus 7, 12, and this is minus 3I minus 6 plus 2, minus 4I. Minus 2I minus 3I, this is minus I, minus 2 minus 1, this is minus 3, 6 plus 3, 9, 9 plus 9, this is 18, minus 9I plus 2 minus 7I plus 21, so this is 14I. Similarly here 6I minus 3I, this is 3I, 9 minus 2, this is 7 here. So this is AB matrix. Now we find conjugate of this AB matrix. So we get here 2 plus 4I, 18 minus 14I, and minus 3 plus I, and 7 minus 3I. Now we find here product of the conjugate of A and B. So conjugate of A and conjugate of B, conjugate of A is here 1 minus I, 3 minus I, 3, and conjugate of B here 2 plus 3I, minus 2I, 3 minus 7I, 3 plus I. So we multiply this conjugate, we get here if we multiply first row by first column, we multiply 1 by 2, we get 2, 1 multiplied by 3I, this is 3I, minus I multiplied by 2, this is minus 2I, minus I multiplied by 3I, we get minus 3I square, so this is plus 3, and I multiplied by 3, this is 3I, I multiplied by minus 7, this is minus 7I square, so this is plus 7. First row multiplied by second column, we get here. Now we multiply this. Conjugate of A matrix and B matrix. We multiply here. A conjugate, this is 1 minus I, 3 minus I, 3, and B conjugate is here 2 plus 3I, 3 minus 7I, minus 2I, 3 plus I. When we multiply first row by first column, we get here 2, 1 multiplied by 2, 2, 1 multiplied by 3I, this is 3I, minus I multiplied by 2, minus 2I, minus I multiplied by this, plus 3. I multiplied by 3, this is 3I, I multiplied by minus 7I, this is minus 7I square, so this is plus 7. First row multiplied by second column, this is minus 2I plus 2I square, so this is minus 2. Plus 3I and I square is minus 1. Second row multiplied by first column, so 3 to the 6 plus 3 to the 9I minus 2I minus 3I square, so this is plus 3, and 3 to the 9 and 3 7 the 21I. Second row multiplied by second column, so this is minus 6I plus so this is minus 2, and 3 to the 9 plus 3I. Here we can see that this 2 plus 3, 5 plus 7, this is 12 here, and this is 3 plus 3, 6I minus 2I, this is 4I here, and you can see here this 3 plus 9 plus 6, 6, 3, 9 plus 9, this is 18 here, and 9I minus 2I, this is 7I minus 21, so this is minus 14I here, and this minus 2 and minus 1, this is minus 3, and 3I minus 2I, this is plus I here, and 9 minus 2, this is 7, and 3I minus 6I minus 3I. So you can see here product of the conjugate of the product of matrix A and B, this is equal to, you can see here, this is the product of conjugate of A and B, which is equal to the conjugate of AB matrix. So we can see that conjugate of the product of two matrices is equal to the product of the conjugate of that matrix. Thank you.